the wire goes in the straightening device. Then it goes over the rolls to the machine, to the second straightener, and it goes further to the cutting advance, and this is the cutter, and then the bending unit, the buckle forming unit, and then exit to the cardboard and eventually to the magnetic table. Control panel. We have all single functions with single buttons. Then we have the computerized length adjustment as well as speed adjustment. Here we have the spinning adjustment with this button. So all functions can be, while setting, adjusted singularly. Okay? We have now started the machine. Jetzt spiegelt er. This is the buckle forming device. This is the exit. And over here we have the adjustment, the centering of the buckle former. That's a manual lever. This one is a manual lever. We adjust the centering of the buckle former. To the center of the given length, and this is done on a nonius. I will show you the this is the lever, and the adjustment is done on the nonius, which is down here, the millimeter scale. This is where the hangers come in. And this is the forming device. The speed of the function is according to the length, because if they get longer you have to go slower, otherwise you will not be able to have them straight. This is the oscillating spinner. And in fact, that is more or less all the machine has. See the length over here and the speed it is running at. And this is the counter. It counts backwards. You say you want 5,000 pieces to be made, and it counts them, as you see, backwards. At 5,000 it would stop, the machine would stop automatically. This is the advance, the drive. This is the knife, close view of the knife. I'll show it to you from the other side. Again, the bender. The bender can receive different molds which you could order. It's pneumatic. That's the huge cylinder behind it. And the cut pieces come down and away in the box. Separating spirals and giving them out singly to the other side, to our binding machine, to the R6 PVC. The question is often put to us, is it also for metal spirals? The answer is no, because metal spirals are made directly in the machine. They're formed and shot in the book directly. PVC spirals have to be made on a thermically deforming machine. You do not see the separated ones now because they go from underneath and away to the machine. This is the jig up. It makes spirals coming from virgin wire. The wire goes into the former, which is down here, and the former shoots the spiral out on the canal. This is now the front view where the operator stands. As we see, the wire comes down from the top and the former is over here. The former is this one, and the canal where it delivers to is here, and over here we adjust the length of the spiral, which is supposed to be digitally with increments of tenth of a second. It's a timer the timer adjustment. We can give the tenths of seconds in increments of hundreds. So you can have an adjustment loop per loop. We have 3 models. We have a basic model without the cutter. This is the cutter. This is the cutter. It's automatically set so that at the end of the length it cuts. And then we have it with cutter, like you're seeing it here. Then we have it also with a packing device where this canal, which receives the cut pieces, would swing and fill the box. For that you need additional controls and an additional counter which comes in the back of the machine behind the canal. Now we'll let it work so that you see how it functions. The advantage of this system is that the pitch is very exact because we use components of our R6 binder. And the piece which is made here can be as long as you wish. We can elongate the canal, or you can elongate the canal with cardboard or whatever if you need longer pieces, but usually they are A3 or A4 size which fit the canal. These forming heads are interchangeable. The advantage is you can put the pitch you want and the diameter you want, and you get, let's say the first one would be like it is here, 20 millimeters, 6 millimeter pitch, and if that job is finished you can put 6 millimeter and 5 millimeter pitch, 6 diameter, 5 millimeter pitch. You can go as high as 38 or 40 millimeters. We have machines working on 38. We do not make it larger than that because it becomes, the wire becomes very heavy, and we have to change the motor because we will not have enough power in it to form 1.8 millimeter wires. We go with wire 0.8 to 1.5 millimeter, giving a diameter of 38. This is a 1.2 wire which we use for the 22 millimeters. Those were the spirals we just made. The machine would make about 2,500 pieces an hour. I'm talking about A4 size pieces.